Hello friends, in this video I am going to discuss correlation, scatter diagrams, Karl Pearson correlation coefficient and rank correlation coefficient. Now before that we should know two terms. Suppose univariate distribution, bivariate distribution and multivariate distribution. Variate distribution. Okay. Bivariate distribution and multivariate distribution. Okay. Now univariate distribution means suppose single variable is there, suppose age. So age may be 2, 5, 10, 13, 20, 26, 30. Clear? So it is univariate distribution. Single variable is there, it is called univariate distribution. Now bivariate distribution means suppose along with age, weights are there also. Okay. So along with age, weights are also there. So suppose age say 2, 5, 10, 13, 20 and weights are say 15, 20, 25, 27 and say 45. Okay, so it is called bivariate distribution. And multivariate distribution means so more than two variables are there, say age, then weight, okay, then height, then gender. Okay. So more than two variables are there, then it is nothing but multivariate distribution. So often we come across a situation in which our focus is simultaneously on two or more variables, and invariably we observe that movements in one variable are accompanied by movements in other variables. Okay, so movement in one variables are accompanied by movement in other variables. For example, suppose age, okay, age and weight. Age and weight, here the correlation is there. Here, so we need a quantitative measure of the relationship between the two variables. So we need a measure to quantitative measure to know the relationship between the two variables. Now, what is correlation? So in a bivariate distribution, we may be interested to find out if there is any correlation or covariance between the two variables under study. Okay, so what is correlated? So what is correlated? Now, if the change in one variable affects a change in the other variable, the variables are said to be correlated. Okay, so if the change in one variable affects a change in the other variable, the variables are said to be correlated. So if you change the age, the weights are also changing. Okay, so age and weights, they are correlated. Now, direct correlation. Now we see direct or positive correlation. Okay, diverse or negative correlation. Okay, so if the two variables deviate in the same direction, that is, if the increase or decrease in one result in a corresponding increase or decrease in the other, a correlation is said to be directed or positive. So height, if we increase the height, so weight will increase. Okay, if we increase the income, if income is more, so expenditure will also increase. Okay. So all these are positive or direct. So if they are deviates in the same direction. If income is increasing, it will increase. Expenditure will also increase. Now similarly, diverse or negative, if they constantly deviate in the opposite directions. That is, if increase or decrease in one result in corresponding decrease or increase in the other. So it is called diverse. Suppose if we increase the volume, so pressure will decrease. So the relationship between volume and pressure is negatively correlated, or it is diverse. Similarly, we can increase the speed. If we increase the speed, time will decrease. Okay, so these are the example of negative correlations. Here, next, how to exhibit. So how to make sense the correlation. So how to know the relationship. So they are correlated or not. So there is a concept that is called scatter diagram. Scatter diagram, through which we can make sense the correlation. So it is the simplest way of the diagrammatic representation of bivariate data. So what is scatter diagram? Where say I is equal to 1 to n. So if the value of the variable x and y are plotted along the x-axis and y-axis respectively in the xy plane, the diagram of dots so obtained is known as scatter diagram. Okay. Now from the scatter diagram we can form a fairly good to vague idea whether the variables are correlated or not. If the points are dense, very dense, that is very close to each other, we should expect a fairly good amount of correlation between the variables. And if the points are widely scattered, a poor correlation is there. You can see now, first of all, how to draw a correlation. Suppose we have two variables x and y. Here, now the x values are 1, 2, 4, 6, and y values are 3, 5, 3, 7, 9, 10. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9. So x is 1 and y is 3. X is 1, y is 3. So it is first. X is 2, y is 5. X is 2, y is 5. Okay. Second, x is 4, y is 3. X is 4, y is 3. This one, x is 6 and y is 7. Y is 7. So this is nothing but a scatter diagram. This is nothing but a scatter diagram of this bivariate data. Okay, so it is nothing but scatter diagram. Okay, it is now perfectly positive correlated. So perfect correlation, perfect positively correlated. Okay, now figure B. So strong correlation is there, but it is not perfect. Okay, so strong positive correlation is there, positively correlated, but it is not a perfect. Similarly, here positive correlations are there. So in this particular figure, positive correlation are there, positively correlated, but not strong and perfect. So positive correlation is there, but the relationship is weak. In this particular figure, no correlation is there. So they are uncorrelated. X and Y, they are uncorrelated. In this particular figure, the correlation is perfectly negatively correlated. Perfect negatively correlated. Here, strong negative correlations is there. strong negative correlation is there. Strong negative correlation is there. In this particular figure, negative correlation is there, but the relationship is very weak. Okay, the strength of the relation is very weak. So this is perfectly positively correlated. Strong positive correlation is there. Weak positive correlation is there. No correlation is there. Perfectly negatively correlated. Strongly negative correlation is there. Weakly negative correlation is there. Okay, so in this way we can comprehend the distribution of the data. Next, the problem is here vague answers are there. So we need some numbers through which we can measure the relationship between the two variables. So the first famous widely used technique is Karl Pearson coefficient of correlation. Okay, now see the calculation one by one. So the formula is R is equal to covariance between x and y, sigma x into sigma y. So covariance between xy and sigma x means standard deviation of x, standard deviation of y, and the formula is 1 by n summation of xy minus x bar y bar divided by square root of 1 by n summation of x square minus x bar square by 1 by n summation of y square minus y bar square. Okay. So the question is how to get this particular formula. So how to get this formula? You can see one by one. Say covariance x comma y, that means 1 by n x minus x bar into y minus y bar. Okay, and its summation. So 1 by n summation xy minus plus 1 by n summation x bar y bar minus 1 by n summation x y bar minus 1 by n summation y x bar. Okay, so 1 by n summation of xy plus 1 by n x bar y bar. So summation of constant is nothing but n minus, so this is nothing but x bar, so x bar y bar, and this is nothing but y bar, so y bar x bar. Okay, so this is nothing but x bar, this is nothing but y bar. So finally 1 by n summation xy minus x bar y bar. So you know 1 by n summation of x minus x bar y bar. Similarly, we can calculate the sigma x and sigma y for sigma x, sigma y. So sigma x, it is nothing but 1 by n summation of x minus x bar square. That means square root of 1 by n summation of x square plus 1 by n summation of x bar square minus 2 by n summation of x bar. That means 1 by n summation of x square plus x bar square into n, so summation of n, summation of constant part. Now this is nothing but a mean, so minus 2 x bar square. So this is nothing but x bar. So square root of 1 by n summation of x square plus x bar square minus 2 x bar square. So finally the answer is 1 by n summation of x square minus. Okay, so similarly we can calculate for the sigma y. Now see how to get all these values. Okay, so suppose we have value say 1, 2, 1. Suppose okay, suppose we have two data. So you say suppose it is bivariate distribution. So x say 1, 3, 5 and y say 3, 6, 3. So x bar is 3 and y bar is 4. So we need, so the actual formula is already you know. So 1 by n summation of xy minus x bar y bar divided by square root of 1 by n summation of x square minus x bar square into 1 by n summation of y square minus y bar square. So we have to calculate xy. Already you have calculated x bar, y bar and x square and y square. So see this particular table. So x square, y square and xy. So x square means 1, 9, 25, 9, 36, 9. Xy is say 3, 18 and 50. So summation of x square is nothing but 35. Summation of x y square, summation of xy bar, it is 36. Okay, summation of xy is 36. Okay, now you just so already you have calculated x bar is 3, x bar is 3, y bar is 4, x square is 35, y square, summation of x square is 34, summation of y square is 54 and summation of xy is 36. Now we just put the value. So r is equal to 1 by n. So 1 by 3 summation of xy is 36 minus x bar into y bar. So x bar is equal to 3. So x bar is equal to 3, y bar is equal to 4. So 3 into 4 divided by 1 by 3, x square is 35 minus x bar square. So 3 square, square root of 1 by 3 y square, that is 54 minus y bar square, that is 4 square. Okay, and the final answer is okay. So it is 12. So 12 minus 12 and 35 by 3 minus 9 into 54 by 3 minus 16. So the answer is 0. So the answer is 0 means there is no relation between x and y. So the correlation coefficient between x and y is 0. So they are not at all correlated. And remember one thing, that r value, the r value always should be in between -1 to 1. The r value should be always in between -1 to 1. Suppose, so we can see this particular figure. Now in this particular case, if it is perfectly positive correlated, the r should be 1. Okay, so if they are uncorrelated, so the r value should be 0. If perfectly negatively correlated, so r should be -1. If strong positively correlated, the value of r may be like 96. If the r value is 0.96, we can say it is strongly correlated, positively correlated. Or if value is 86, it is strongly correlated. If it is 8, say 3. So if the values are like this, then we can say the variables are strongly positively correlated. But if the values are like say 0.53 or 0.46, if the R values are like this, then we can say they are positively correlated, but weak relationship is there. Similarly, if the R value say minus 0.93 or minus 0.86, we can say strongly negatively correlated. Similarly, if value of R is say minus 5, minus say 61, minus say 43, then we can say negatively correlated, but the strength of the relationship is very weak. Okay. Now remember one more thing. So the R value, this R, okay, so this R provides a measure of linear relationship between X and Y. For non-linear relationship, it is not very suitable. Okay, so for non-linear relationship, it is not very suitable. Suppose we have a distribution is like that. Okay, so it is X and Y. If you calculate R value will be say maybe say 0.10. So from R value, it seems that near about no correlation is there between X and Y. Okay, but it's a strong relationship is there, but the relationship characteristic is non-linear. Okay, so if you calculate the Karl Pearson coefficient of correlation, it exhibits only the linear relationship between. Okay. Now remember one thing, correlation coefficient is independent of change of origin and scale. Say 1, 5, 8, 10. Okay, and so just take 3 data, 1, 5, 8, and Y say 8, 12, and say 16. So we can use one shortcut method. Okay, so for that the formula of the shortcut method is 1 by n summation of uv minus u bar v bar divided by square root of 1 by n summation of u square minus u bar square 1 by n summation of v square minus v bar square. Now you can, if you compare these two formula, this one, so if you put x is equal to u and y is equal to v, we can get this particular equation. Clear? So what is u? U is nothing but x minus a, and v is nothing but y minus b. So what is a and what is b? A may be the middle value, median of x. Okay, it's a middle value, median of x, and y may be the middle value of y. So median values of this particular y distribution. So assume this is a and this is b. Clear? So the u values are, then the simultaneous calculations are like this way. So u and v. So u means what? X minus a. So a is 5. So 1 minus 5, it is minus 4. 5 minus 5, it is 0. 8 minus 5 is 8 minus 12, it is minus 4. 12 minus 12 is 0. And 16 minus 12, it is 4. So you have to calculate the u square and uv. uv is what? 16, 0, 12. 4 into 4, 16, 0, 2 into 4, 12. U square and v square. So u square is 16, 0, 9, 16, 0, 16. Okay. Now u bar is summation of this. So minus 4 plus 3, it is minus 1 by 3. And what is v bar? Minus 4 plus 4, 0 by 3. So it is nothing but 0. Now summation of uv, it is 28. And summation of u square, it is 25. Okay. and summation of v square, it is 32. Now just put one by one value. Say 1 by n is equal to 3. Summation of uv is 28 minus 1 by 3 into 0. So u bar into v bar divided by 1 by 3. Summation of u square, that is 25, minus u bar square, that is 1 by 9, 1 by 3. Then v square is nothing but 32 minus v bar square, so v bar is 0, so it is 0. Okay, now the final answer is, okay, so the answer is 1.0010. so we can say it is perfectly positively correlated. Okay, so that is the end of this particular video.